So today we'll start a webinar on GazTell specifically. And what we would like you to know, what I'd like to see is if everybody, okay, let's get into this. Okay, so what we're going to talk about today is 4 different subject matters. GazTell series overview. We'll talk about the accessories and special applications that we've seen using GazTell and obviously some of our other gas detection systems. The calibration options that are available to you. And this gets a little bit confusing for a lot of people because your calibration devices are chosen by the type of technology and the type of gas that you're looking to sense. And we'll get into that more detail. And then, of course, we'll end the webinar with some sales support from Rob and tell you all the great things that we have to give you to help do your job, and also some of the markets and stuff like that. So one of the things that some of you who have been with us with our other webinars that we've given is basically that we've gone over a couple of these things in maybe not so detailed fashion on Delphian product line. So we're going to have some review in this webinar, but for those who didn't attend the other webinars, hopefully you'll get something out of this as well. To start off, we have the sensors. We're a fixed point gas detection company, which basically means we can do a sensor or we can do a full turnkey system. And that's important to note because some of the things that you don't necessarily see in the webinars, you should ask us about, because we are capable of doing very specific things, such as sample draw for ovens where you need heat exchangers, specialty enclosures, special systems that might require addressable sensors, for example. So we're looking at a full turnkey system that consists of the sensors, the control systems, the calibration, and special accessories that go along with that. As far as the sensors are concerned, we have 2 sensors that are being sold at this moment, which is the electrochemical GazTell Model 455 and the GazTell IR infrared Model 450. There are 2 sensors that we are presently working on. The catalytic bead sensor, the Model 470, is designed and developed and now at Factory Mutual, hopefully getting its approval within a month or so. The infrared IR CO2 is a whole new line of GazTell that we just introduced and hopefully to bring to the market within several months. That's the Model 510, and of course that's going to be detecting carbon dioxide, which is a whole entirely different market than many of you might have been familiar with up to this point. Go back and talk a little bit about the control systems. Remember that although we're talking about GazTell, there are different parts of the system that you should be aware of. And those of you who have been with us for a while are familiar with our Sage CE system and also the analog and digital controller-based system, which can be mounted either in a rack or a panel or mounted on the wall in an enclosure. And again, that's part of the turnkey systems that I was talking about. If somebody needs a standalone, just a sensor with a 4 to 20 output, we have it. If somebody needs a sensor that's going to go back to a local panel where you can see all your sensors in one glance, then we talk about either the Sage or we talk about the controllers that fit into the flexi racks. The accessories that we have, we're going to get into a little bit later in the webinar, and those allow you to customize the system to the requirements of your customer. If he's monitoring in an oven, if he's monitoring in a duct, we have accessories that allow you to mount the sensor in the duct. We have accessories that allow you to take a sample out of the oven and bring it to the sensor. If it's a heated sample, we can cool it using a little heat exchanger that we can build, or you can do that yourself, or the customer can do that. So the first GazTell we'll talk about is the fixed point IR, which I think we've mentioned quite a few times in our earlier webinars. The beauty of there's several things that we should talk about on the GazTell. The first thing is that it's a small footprint. And there were some things that we've listened to over the years that customers have always been concerned about, which is size, which is power requirements, and of course, cost. And we've been able to achieve all three of these advantages with the GazTell by minimizing the footprint. It's a 5-inch by 2-inch, which is probably one of the smallest IRs that you're going to see out there. We've been able to reduce the power, allow to use only about 77 milliamps per detector head for the fixed point IR. I believe the electrochem and the other types of IRs vary in power requirements. Electrochem are probably down near 40. Catalytic bead will be up near somewhere about 120 milliamps. But it's still lower power than most of our competition out there. Another nice feature about the GazTell is we've designed it to allow use with power from 12 to 42 volts DC. And this is important because not only do you not really have to be critical about the power supply that you're bringing in, you're installing, but it can be used in a lot of different fields. Automotive is eventually going to go to 42 volts, I hear. I don't know if that's going to be within the next 5 years or the next 20 years, but they're looking into that right now. Also, when you hook up this to a battery backup system, what we often found in the past is that when the batteries get to the end of their life, when the battery charging system turns on, they often don't create a good capacitor and allow the voltage to spike to 35 volts. On some of the older 24 volt or 12 volt systems, if your battery backup system spiked, you could easily blow out by a surge. You could blow out the detector head that's attached to that battery backup system. So now with a 12 to 42, if you do get a spike at 35 volts, we should have suppressed all the bad things that will happen when that does happen. As far as some of the other things, I don't want to call it a me too, but one of the things I always get concerned about is people looking too much into the accuracy and the response time. Everybody has to meet factory mutual on a lot of these products, and therefore, although somebody might claim a second or two quicker response or a percentage point more accurate or repeatability, we're probably all in the same range. It's just how we choose to describe our accuracy and our response times that makes it different on paper, but actually they're all the same. And that's important because we often have customers say, well, I like yours, but your competitor is 4% accurate and you claim 5%. Well, that should be meaningless when you're talking about gas detection, because what's more important is repeatability and accuracy as far as giving you an alarm when a gas leak happens. Also remember, these are fixed in space point detectors, which basically means that wherever the detector is, it's only as good as if the gas gets to that point, which basically means if I had two detectors 2 feet apart from each other, one detector theoretically could go off while the other one didn't because the gas was higher concentration at one of those detectors rather than the other. So they're point in space monitors, and you should be aware of that when you buy them, when you figure out how many do you need and where you place them in a particular room or application. The mean time between failures, the MTBF on all our GazTell series is 8 years, and that's electronics. Basically, the unit itself with the electronics are all rated for at least 8 years. We've found with the determinator, we have many units out there that are basically approaching, I'd say, between 12 and 15 years old that are still operating very well. But just be aware that calculated MTBF is 8 years. And of course, when you start going to other sensors, you have to look at the sensors that are plugged into the electronics to actually get the longevity of a specific gas detector head. We talked about in the earlier webinars, we talked about the optional modules, the XMO, the SLAM, and the COMO, and we'll show you a little bit more about that in slides ahead right here. The fixed point IR is again, is a infrared detector that uses optics to actually sense the presence of gas. And it's very simple. We're not going to go over the fundamentals. We did that in an earlier webinar. But basically what it does is it has a light source and a detector at a specific wavelength. And when gas comes in between the light and the detector, it absorbs the energy produced by a specific wavelength of light, and therefore the detector sees less of a signal than if it was just clean air. And of course, with electronics and algorithms and software, we can determine what the concentration of the gas is just by the amount of light that's absorbed. As you can see by the picture, by the way, the optical chamber is very, very small. And the amplification of signal, if you could imagine how much a photon of light can absorb one molecule of gas, you can see that the amplification of the signal is critical in giving you good gas detection. And that's where success or failure is when you design a gas detector, that you have to make sure that everything works together as a team. All the algorithms for monitoring moisture, for monitoring absorption of light, for drift over time. And this is where we've proven ourselves over and over again, because the technology here is the same technology we use in the determinator, the IR determinator, which has now been out in the market for about 17 years. Okay. The next technology we're going to talk about in the GazTell series is catalytic bead. As I mentioned earlier, this is not yet sellable. We are waiting for the final approval from Factory Mutual. They're doing their long-term studies right now. We've passed performance and we've passed hazardous location. So we're well on our way and really just waiting for the long-term stability to pass, which we have no doubt it will. Again, the beauty of this is all the GazTell sensors all use the same body. It's the 5x2 body. It's the same 4 to 20 output. It's the same power requirements. So everything is identical. What changes is really the sensor, and in some cases the front end electronics to operate the detector, the sensor element itself. MTBF is always the same. Warranty is typically the same, except for electrochemical. You'll see that the cells are warranted for 1 year rather than the life of the unit, which is 2 years. And that's just really a function of the electrochemical cell. The beauty of the catalytic bead GazTell is that the elements themselves are replaceable. And what we've done is we've designed a very similar to our 550 common sensor. We've designed replaceable elements, and these elements can be removed from the bottom of the sensor when you remove the flame arrestor. This allows you to buy a sensor body, a detector head, and use it for your 10 to 15 years and just replace the element at a much lower cost than replacing the whole sensor itself. Okay, and a lot of competition, you have to replace the entire sensor for the cost of the body as well as the sensor. The other thing we've improved over our latest catalytic bead sensors, if you notice, we've put screens around the catalytic bead reference and active beads, and this prevents big fingers from destroying the bead when you place the sensor in the body when you're replacing the elements. Very important, because we found that if you're not careful in handling a sensor, you have to remember that the sensor itself is the most fragile part of the detector head, and because it's a catalytic bead mounted on a 1 mil platinum wire, they can be damaged very easily by your finger, by a tool, by a screwdriver. Like our 550 system, the catalytic bead GazTell is going to be capable of monitoring generically a whole slew of combustible gases. These gases, if you actually looked at combustible gases and you Googled it, you'll find that there's probably 5,000 different gases that are considered combustible. Although we haven't done them all, and in fact there's probably not a market for all, you can see we've done quite a few. I think we've done about 63 gases over the years for a catalytic bead. So what happens is when you buy a catalytic bead, that catalytic bead can detect any one of these combustible gases that exist on this list, at least. Not all of 5,000 are detectable, but the ones that we've accepted on this list specifically can be detected quite easily with just a footnote that we haven't actually done a video yet on this, but eventually we will. The GazTell, if you have a sensor that you're looking for, like example, let's say you're looking for benzene. Benzene is different than heptane, which is different than ethanol, which is different from isopar H. Therefore, if you wanted to be accurate in detecting a specific gas, you would have to go into the sensor's submenu, the info menu, and set it up with a transfer factor specific to that gas. Methane is considered the main gas. Methane is typically the gas most people use to calibrate. This is for good reason. Methane has a high ignition temperature of 999 degrees. It also is readily available. It's also very inexpensive. So when you use methane to calibrate your sensor, you're doing a couple of things. You're making a cheap calibration, inexpensive calibration, I should say. You're also making sure that because you're calibrating it with methane and it detects methane, you're proving that the sensor can detect all of the other gases that you might want to use the sensor for. For example, gasoline has a ignition temperature of about 535, I think, somewhere in that vicinity. Methane is ignition temperature is 999. This means if you've proven that it can sense methane, then you guarantee that gasoline can also burn on that same element because its ignition temperature is much lower than methane. And that holds true for all these chemicals that you see on this list. I think the only one that I know, there's only one or two chemicals that I know that have a higher ignition temperature than methane, and they aren't detected by this sensor. But it's not a common chemical, so you wouldn't necessarily see it out there. GazTell electrochemical. Okay, right now, if you look on the bottom of this slide, you'll see all the gases that we're capable of doing right now using this GazTell electrochemical detector head. The difference being that the electrochemical cell, when it is replaced in the body, can see different types of chemicals. And you can see ammonia, carbon monoxide, chlorine, ethylene oxide, and so on and so on. Oxygen is the only one that, although we call it a toxic gas detector, oxygen's really for oxygen deficiency, and it monitors 0 to 25% by volume, rather than all the other ones on the list there that are all part per million sensors. And when we talk about part per million, it's because these sensors, this GazTell electrochemical detector head, is really used for safety. This is not to look for explosions, not look for high concentrations, not really even intended for leaks. It's intended to monitor so that people are safe in the environment that they're working in. The way the electrochemical cell works is like the catalytic bead. It's a plug-in PC board into the bottom of the, when you remove the flame arrestor, it exposes the PC board that you plug the cell into. The beauty of this is that you can buy one gas detector head. 365-450-501 is a GazTell detector head part number. And once you buy that, you can take any one of those gases that we sell for, okay, any one of these that you can buy a cell for, plug it into the detector head, and the detector head will recognize what cell you're plugging into it and set it up so the scale and the range is for that particular sensor. If the sensor, such as hydrogen sulfide, has multiple scales, such as 0 to 25 ppm, 0 to 50 ppm, or 0 to 100 ppm, you can then go into the info menu, which again, you can look in the manual and see how that works. But you can go into the info menu and actually select the scale that you want to use with that particular electrochemical cell. We have 3 videos that we're going to be showing you today. One of them will be set up, and that will show you how the info menu works. The fourth on the series of GazTell would be another infrared product, specifically set up for carbon dioxide. Everything that I said earlier holds true for this one. You can notice the size is the same, the voltage is the same, the LED is the same. The only thing we change is the front end electronics, which now operates the IR for carbon dioxide rather than, for example, the IR for methane, which would be a different front end. And when I say front end, what we're talking about is actually the detector and possibly the light source. Okay, the detector on the CO2 is in a wavelength that allows carbon dioxide to absorb that light energy. Whereas if you go back to the GazTell IR for methane, it's using a detector that's set up specifically for the wavelength energy of methane, which would be about 3.3 microns. It too uses the identical optics chamber, which is a gold-plated chamber, very small, and allows the gas to diffuse through the flame arrestor, through the whole optical chamber, and then get to the light source and the detector head so that CO2 can be absorbed. Let's talk about the construction of the detector head a little bit. And some of the things that we like to tout is that the detector head is, of course, explosion-proof, FM class 1, Div 1, group C and D, and it's environmentally protected because it's an epoxy. It's actually a coating that a powder coating that allows the surface to be coated so that high corrosion materials such as maybe chlorines and other corrosive materials can't get to the aluminum metal. So although it's not stainless steel, it does have a NEMA 4X rating on it. The way we've done this, I don't know if you can see what I've done here, is the numbers 1, 2, 3, 4 through 7 are shown on this, so that as I'm talking, you can actually see the locations of which I'm talking about. Number 3, the internal components and connectors are gold-plated. This is very important, and you really should be making sure that any gas detector that you put out in the field has gold-plated components. And you can see that here's the programmer, that's gold-plated, and right here are gold fingers, which are plated that go into the connector. It's a Euro connector. It makes it easy. The Euro connectors are nice because it makes it easy for you to wire it up because they could be unplugged. You don't have to wire it in the housing. You can bring it out, wire it up, and then plug it back into your body. Number 4, sensors are designed to withstand hot plugging. This is also important because in areas where you don't have to declassify the area, it might be just as simple to open it up, unplug it, do what you need to do, and plug it back in. Just be aware, in Class 1, Div 1 locations, you have to declassify an area if you're going to open it up and expose the plus and minus 24 to the environment. All connectors are uniquely keyed. This prevents this saves me a lot of time because customers don't have to call me and say it's not working, and I'll tell them to reverse the polarity, and then all of a sudden it lights up. So really, you only have one choice on how to plug this in, and it's keyed. And again, you can see the keying right here, and of course they fit into these very specific keyed slots, so you can't put this in backwards. Number 6, the detector head electronics are encapsulated. This is one of the more important features that we have on the GazTell, and in fact, Delphian has always been a big believer in encapsulation. If you're familiar with the 550 system and determinator, all the electronics are potted, which is encapsulation. The environment can no longer get to a board level component because they are encapsulated in a black epoxy that prevents the elements from getting to the electrical parts of the PC board. That is important because most of the time these things are put, when they're put outdoors, you have a lot of nasty stuff going on, whether it be chemical or whether it be condensation in conduits. You want to avoid the water from shorting out your PC board, one of the bigger problems that we see out in the field. And we've never really had a big problem with that because, all our components are always encapsulated or potted. The last thing that I think is unique to Delphian is that we have come up with a proprietary method of treating our flame arresters so that they are anaerobic. Okay, which basically means that which basically means that it will repel the water, whether it be rain or condensation. One of the enemies of a gas detector is that you can't allow water to get to the inside of the unit, because with a catalytic bead, it'll short out the beads. With an IR, water and water vapor actually absorb light. And if they absorb light, it's going to look like an actual gas leak. So if you can see by the picture here, we put two flame arresters, similar flame arresters, in a little crucible of water. And you can see once we put it in, that the one that is not anaerobic is filled with water almost immediately. Whoops. Filled with water immediately, where the one that has been treated, which is number 7 with the red line, actually shows you that it repels the water and the water can't go through the flame arrestor. And that's a very important feature. Okay, at this point, we're going to play a video for you, and it's going to be the installation video. I believe it's only 3 or 4 minutes long, so bear with it. It's some good information. All these videos basically are for you to use, for you to give to your customers. They are on YouTube. They're also on the Delphian website.
In the installation, mount the detector and its optional modules if required onto 3/4 inch NCT conduit, making sure the conduit is properly secured. In many applications, the detector will be suspended from the conduit in open areas, such as ceilings. But if mounted against the wall, it is advisable to place a bend in the conduit to allow easy access to the detector when moving or when a foam splash guard might be used. These modules can be mounted up to 400 feet between each other and the detector head. Once the components are mounted, wiring them up can be accomplished by pulling a 5-conductor cable between the individual modules and 2 or 3 conductor cables for power supply and signal out, then terminating using the supplied 5-pin terminal block. In this video demo, we have used short lengths of conduit, therefore short wire runs, but you will need to pull the cables through the conduit using the typical pulling techniques. Once the cables have been pulled through the conduit, terminate the wires with the 5-pin terminal block supply. Make sure the wires are secure by giving them a light tug. Then plug them into the 5-pin socket inside the housing. Five conductor cable is to transmit the 4 to 20 amp signal and the RS-485 communication between the detector and the accessory module. The remaining two wires will supply the plus and minus DC power. The units require both the top socket and the bottom socket are identical, and the plug can be plugged into either end. But obviously, the socket closest to the entry point makes more sense. SLAM will require additional wiring for the 3 relays available for alarms. Each relay has a common, normally open, normally closed connection. Read the manual for more detail on wiring. Once all the cables are connected, you can make the last connection to power and power up the system to make sure all the modules turn on properly. For this video, we will close them all up before we supply the power. The detector access port plug is reinstalled into the body first by hand, and then secured using the optional flame arrestor access port tool. This tool has 2 pins that easily insert into the plug or flame arrestor to easily tighten them. The covers on both the SLAM and the XMO are secured using the supplied 4 to 20 bolts. Make sure you clean the metal surfaces of the cover and the body before placing the cover back on. Secure the bolts using a 7/16" wrench or socket. As you can see, I have chosen to hang the covers off the bottom bolt hole of the body to prevent contaminating or misplacing the SLAM cover, preventing strain on the XMO display cable if it were just to hang there. Once completely closed up, you can supply power to the system to ensure your system has been installed properly. If 9 to 42 volts DC power is supplied, the detector and XMO will display warm-up for approximately 40 seconds, while the SLAM, if it's installed, should be blinking green. This concludes the installation portion of the GazTell 450 video.
Okay, I hope the audio was good enough for you to hear on that. But if not, again, as you can see, you can go to your Delphian website, website, or you can actually search this on YouTube. It's on YouTube as well, and YouTube is the way I usually go when I'm talking to customers, because that's easy for them to do. Okay, so let's talk a little bit about accessories. We won't go in too much detail. I think it's more important that you know that we can do some turnkey systems and what some of them might be, rather than actually just memorizing parts and numbers and all that stuff. So you're always welcome to give us a call to get more information on a specific application. As you can see here, we have many different accessories. We can mount things in enclosures from very small to huge enclosures with windows, without windows, with hinges, without hinges. We can also do sample draw systems, which consist of a rotometer, a ductor, and a 3-way valve, so you can switch it between the sample location and the calibration devices. We have other accessories such as the foam splash guard, and the sealing cone, which allows accumulation of gas into the detector head. Quick couple of notes. Our foam splash guard is very unique in the industry. We're very proud of it. We've had it for 30 some odd years, and basically it's a very specialty foam. It's a proprietary blend of plastics that are very UV resilient, which means that it will basically last you, we normally see about 2 years life if it's exposed to the sun on a daily basis. And if you know anything about plastics, most plastics are not UV tolerant and therefore decay quite quickly in sunlight. The other thing that you should be aware of, I don't know if you can see by the chart, by the way, all this information that you see here is available on a data sheet, available on the rep website as well. But one of the things unique to Delphian is that you can see that our foam splash guard, here's the curve with no guard at all. Of course, that's your best scenario, and if you can live with that, that's your best way of detecting gas in the most expedient way. If you have to use a guard, you can see that the Delphian guard only adds a slight delay on diffusion of gas. And this is primarily because the actual configuration of the foam is an open cellular foam that allows the gas air to pass right through with little obstruction. And then, of course, when we go to competition, we look at the baffle type splash guards of our competitors, and you can see they reduce, believe it or not, they reduce significantly the speed of response when you put this over the bottom of the sensor. We talked about this in earlier videos, but just to complement the GazTell detector head are these GazTell modules. The XMO, standing for extension module, the SLAM for simple local alarm module, and the COMO for communications module. The XMO being probably the most important in the series because that allows you to extend your detector head into locations where the sensing of gas is the best place that you can place it for success, where the XMO is placed at eye level, down at the ground, or where the technician can get to easily, and this allows you to see what's going on at the detector head. It basically mimics the GazTell detector head display. It is also FM Class 1, Div 1, Group C and D, as all three modules are. The SLAM is the next module in the series that's probably of most importance because that's what you're going to use to actually trigger alarms. Although the detector head has a 4 to 20 output, in many cases you might want a horn, a light, a relay contact out in the field, maybe to even to do an emergency solenoid shutdown where you shut down the electricity or you close a valve where the gas is leaking from. And this relay, the relays in the SLAM are rated at 6 amps, which are pretty much hefty enough to do most jobs. The only time I recommend going to an auxiliary relay is when you have maybe some fans or motors that are running at greater than 6 amps, maybe a 10 amp ventilator. And in that case, you'd want to use an auxiliary relay to do the job and allow the SLAM to energize that auxiliary relay. The COMO is used when you have applications where you want to talk to a PLC using Modbus RTU communication. And this actually allows an addressable location to a sensor. So when you attach a COMO to a detector head, it now is addressable and then can be put onto a PLC of your desire, or a DCS system, or anything else that requires addressable communication. Okay, again, the setup videos, short little videos showing you how to set it up. This is going to be important when you want to see things like how to go into the info menu and change the parameters of the GazTell detector head.
Shown here are the detector head, simple local alarm module, also known as the SLAM, which is a relay module for low, high, and fair relay contact loaders, and the extension module, also known as the XMO, which is typically used when the detector is installed in locations that are inaccessible for viewing, or to make it easier to perform calibration, such as up links, or if they are mounted down into pits. These modules can be mounted up to 400 feet between each other and the detector head. Before actually using the GazTell system for the first time, the user must set up the components to operate to the specifications of his application. begin the setup, declassify the area if it's installed in a hazardous location. Then remove the power from the system. Remove the core to 20 bolts that secure the slam cover using a 7/16" wrench or socket. As a tip, I often use one of the bolts and hang the cover off the side of the housing to prevent misplacing or damaging the cover. Located on the slam PC are jumpers that allow you to choose the alarm level, both low alarm and high alarm. The bottom group are for the low alarm. The top group are for the high alarm. There are 3 relays, one for low alarm, one for high alarm, and one for fail alarm, and 3 sockets to wire to these dry contact relays. These relays are single pole, double throw, and rated at 6 amps. 4 of the jumpers allow you to choose whether you want the alarm to be normally energized or de-energized, and latching or non-latching. By placing the jumper across the 2 terminal pins, you can choose the options. The 2 jumpers on the bottom are for the low alarm. The 2 jumpers on the top are the high alarm. The remaining jumpers are to select the actual alarm concentration triggers for the low and high relays. For more detail on actual jumper position definitions, please refer to the manual. The last jumper on board is dedicated to 125 ohm termination resistance. It is necessary to terminate the RS-485 data lines only if transmission data is corrupted or intermittent. These resistors are placed on the extreme ends of the data lines. Again, for more detail, please refer to the manual. Once configured to your requirements, the slam can be closed up by reinstalling the cover using the 4 to 20 bolts. Make sure you clean the metal surfaces of the cover and the body before placing the cover back on. Use the 7/16 wrench or socket to secure the bolts. To set up the detector for operation, the power must be turned on and the detector head must be operational. The system will go through an approximately 40-second warm-up before being operational. At this time, you will see the XMO and the detector head displaying warm-up, while the slam, if connected, will be blinking green. The Delphian magnetic calibrator is used to activate the magnetic Hall effect switches located behind the label. Blue end activates all blue-colored commands, while the red end activates the red cal command. To initially set up the detector head for the first time, and any time in the future if you want to change the configuration, place the blue end of the calibrator over the info mark on the label for 5 seconds. The first menu displayed is highest reading. This is the highest reading since last calibration. Holding for 1 second over info mark moves to the next information item. Days since last calibration is self-explanatory. Days in service is also self-explanatory. The next item is high and low temperature. To display the values or reset the values, hold for 5 seconds over the info mark and release. Highest and lowest temperatures will be displayed. To reset these values, hold for another 1 second. To bring it back to the main menu, hold for 5 seconds. The next item is last error. If an error has occurred during normal operation, it is saved and displayed here. Another 1 second hold brings us to serial number. This is where the serial number is stored for future reference. If a slam is installed, the slam status will verify the slam settings configured in the slam. Hold for 5 seconds over the info mark to bring you into the submenu to view these settings. A 1-second touch over the info mark will jog you between low and high slam settings. And as done before, 5 seconds will bring you back up to the main menu. The next item in the information display is the alarm delay. Here is where you can choose to delay an alarm by up to 5 seconds. This is often used where users want to be sure the concentration of gas is present long enough to warrant triggering the relay. As you can see, if you don't hold the magnet over the info mark long enough for the 1 second, it will ignore the command. Target gas is where you can choose another gas if one is loaded into the detector head. Methane is the default gas. Other scales can be chosen if the selected target gas allows it. Methane can be selected for % LEL or % by volume. Again, this can be performed by holding the calibrator over the info mark for 5 seconds. Current output gives the user a choice of either a standard 4 to 20 milliamp signal or a 1 to 5 milliamp signal output used by Delphian analog controllers. Display brightness can be modified. If positioned in the sun, for example, you might choose to brighten the display. All alarms and informational messages are displayed at maximum brightness regardless of the setting. Again, use the magnet, hold for 5 seconds over the info mark, bring it to the submenu routine, and then 1 second intervals to change the intensity. The last item in the information menu is software version. This displays the version of the software being used. After setting or configuring your detector head, place the calibrator over the cancel mark for 5 seconds to return to normal operation of the detector. This can be performed at any point when viewing the info menu. This concludes the setup portion of the GazTell 415 video.
So you can see by the videos, these can be very, very useful for customers after you've made the sale, because it'll be sort of a verbal manual on how to do some of the things that they need to do. And again, they're also available on your website and also YouTube. So let's talk quickly about some of the specific applications that we've done and can do. One of them that we've been it's been very popular over the years, especially in gas remediation applications, which is landfills and specifically California area, is what we call the GazTell white pipe. Now you got to be careful. There are special codes, especially in the Los Angeles area, that will not allow a PVC type cap. There are other ways we can do that. So if you're interested and you've got specific needs that won't allow PVC, we can do it with other methods. But this is the most popular method throughout the country, which is basically taking a Y pipe, putting it in your 4 or 6 inch riser, and then allowing the GazTell to monitor the gas inside the pipe. Now, most of the time, you're not going to use GazTell in the % LEL range for this, because gas remediation usually has high concentrations of methane coming up from the ground. And that could be in anywhere from 5 to 25% by volume. So this is really a good application for the GazTell when it's set up for % by volume monitoring. Ported adapters are a real important feature on the GazTell. And the reason is, as I mentioned earlier, when using an Exmo, let's say you have to place a sensor maybe above a dropped ceiling. Well, you're not going to be able to get to that sensor very easily to calibrate and obviously see the display. So you'd put it above the ceiling, you'd use an XMO, bring it down to floor level, and using the port, which is just a port that allows a connection of a 1/8 inside diameter tube being brought down to ground level. And at ground level, then you could use the XMO to mimic the functions on the detector head itself and do all the calibrations and actually port your gas up to the sensor. It could be used in confined space areas. It could be used in, we've seen it used in elevator shafts. Some applications are in hotels. We've used it in the stairwells where the stairwells were so high that the technician couldn't easily get to that detector head to calibrate. So it's a very popular option. When you're monitoring for gases in ducts or maybe an oven or something similar, the way to go is what we call sample draw. And the sample draw, as the picture depicts, is a sensor connected to a three-way valve, connected to a rotometer so you can adjust flow rate, connected to an eductor. An eductor is basically a device that uses the Venturi effect to, when you put shop air or any type of air on the one side, it pulls a vacuum on the other. And then going through the eductor, you can, eductors actually can suck up a very high volume of air. So, oh boy, sorry about that. So when you use an eductor, you need a rotometer basically to control the amount of flow because you don't want too much sample coming out of your duct or your oven. These components are readily available at Delphian. You've got the part numbers. Again, this document is readily available on your rep website. And the difference between the ported adapter and the reclamation adapter is that the ported adapter has one elbow to send gas up to the sensor, and the flame arrestor is open. With a reclamation adapter, we close the entire flame arrestor opening, and now we have an inlet and an outlet. And that's the difference between the two ported and reclamation adapters. We also have available for very specific applications. If a guy needs possibly a quick standalone unit, we do have what we call a wall mounting kit that consists of a bracket and a very simple 12 to 24 volt power supply. It allows you to connect one GazTell head in one location, and as long as you don't need maybe alarms, bells and whistles, and the XMO, this will work very well. If you do need a relay, a light, a horn, or something else going out in the field, you can add a slam to this, and it will allow you to connect those alarms to the slam. So now we're into calibration kits. We have several different calibration kits that are available for specific gases or types of technologies that we use. The most common calibration kit is the Type A flow kit, which is basically a cylinder of gas, usually 105 liters, and that will allow, using a regulator, for you to flow gas at 1 liter per minute over your sensor. Now, this is typical in applications where your gases are not dangerous to the user. And for example, methane, if you're calibrating a GazTell IR methane detector, the use of calibration kit such as a Type A flow kit is probably the best way and the only way that you can easily and cost effectively apply gas to the sensor. They also have carrying cases that allow you to put all your tubing and your regulators and the tank inside the carrying kit so that you can carry it around when you need it. The static calibration kit is slightly different. Delphian has always been concerned about the user as far as two things. The danger level in applying toxic gases to your sensor, and also the cost of performing a calibration. A lot of the competitors still use ampules. Ampules could be $8 a piece for a calibration. The beauty of our static cal kit is that you can get up to 400 calibrations out of a cylinder, which is quite a few calibrations when you think about the cost of performing a calibration. The way this is done is quite simple. We allow you to inject a very high concentration of a gas in a very small volume. So we take advantage that we have a cylinder filled with, let's use hydrogen sulfide as an example. We have a cylinder of gas of 1,000 ppm, and when that valve on the top of the cylinder is open, we allow the gas to flow into a very specific volume, a 1.2 cc volume. Using the pressure gauge, we've converted pressure over actual parts per million, so that when you open this valve up, you can then fill it to a specific 15, 20, 25 ppm. And when we turn this three-way valve, we allow this amount of gas that's in this 1.2 cc volume to be expelled through this hole into the chamber. And when it comes to equilibrium, you'll have an exact 25, 30 ppm exposed to your sensor. The beauty of this is that you never really flow a high concentration of dangerous toxic gas over the sensor and expose the technician to those levels of toxic gases. And this is really, really important, especially in confined space entry areas where you don't have that much volume of air to begin with. This type of static kit right now is used for hydrogen sulfide and carbon monoxide. It's also used in mercaptan as well. The third calibration kit option that we have is the gas calibration generator kit. This is actually a very unique device that allows you to make your own calibration gas, very specific flow rate, very specific calibration. It's a one-shot type of operation. In other words, when you buy your calibration electrochemical cell, you have to specify the speed that you want, the flow rate that you want, and also the concentration. This cell is then plugged into the bottom of the unit, and it immediately starts flowing gas through your tubing and to your detector. We'll show you a quick video. Okay, well, maybe we won't show this. If you want to see the calibration video, you can go again to the website or YouTube and you can see how to calibrate. This was just an example of one of the technologies and the type of calibration kit that allows you to calibrate your GazTell detectors.
Yeah, we'll go ahead and run it after we talk about the value for anybody who can stay around after the 1 o'clock hour. Just, Scott, thanks for going over the GazTell series overview. It's good for us to see what all modules, what all adapters, support equipment, customization capability that we have with GazTell. And I felt that the presentation provided us with the ability to see that. So when we walk away, the GazTell value that we see is, first of all, is your stability and your performance of the sensors. Most of these sensors are patented right here at Delphian. Delphian, as you all know, is an entrepreneurial company. It's very focused on the quality and also on the being able to support anybody with any questions at any time. So getting right into stability and performance, if you look to the right, that picture shows you one of our test fixtures up on the roof that houses the sensors and exposes them to all the environment. You know, having said that, the infrared GazTell has stayed within a 5% accuracy. We quote 5% accuracy. It stayed within the 5% accuracy for 4 years up on the roof. The electrochem stayed within the 5%, and it's been up there for 12 months without a recalibration. The catalytic bead, the same thing. It stayed within its 5% accuracy. It's been up on the roof for more than 12 months without a recalibration. So that's pretty impressive. That so it demonstrates your stability and your performance in the unit. Even though, as Scott mentioned earlier, that 5% may have come from a minimum requirement from the FM specifications, we definitely are better than what's requested. Low cost of ownership, another high value reason why. It's minimum maintenance and long life. I know Hugh Avery's on the phone. Hugh had done an example of the cost of ownership of the infrared versus a competitive unit that was out there that needed to be calibrated every 30 days. And it was in the thousands of dollars after 4 years to do 8 sensors. So Hugh was able to win that program quite easily, showing him the lower cost of ownership of the Delphian infrared technology. Economical. We all know this because everybody's got their demo or has seen the demo. It's a unique design, and Scott went through that design. We've costed out a lot of the expenses that are typically found in a standard run-of-the-mill process transmitter head, yet we still maintain the same certifications, the Class 1, Div 1. So you have an economical advantage. We know that the IR unit's $690. I've been told by some of you that it's as high as $4,000 for an equivalent unit that has no better performance, and anywhere between $1,200 and $4,000, and we're at $690. We do have a huge advantage there. Secondly, the photo that you see here is showing a confined area where we have a competitive unit and we have a GazTell sensor monitoring mercaptan at a gas compressor station. So you can see the size difference. I believe we're the smallest footprint out there, which is going to translate into savings to the customer. Your delivery, we have a large stock of parts. We can usually get everything out within a week. There are some instances where, due to production and other parts, that it might be several weeks. Versatility. We talked about the extension module, the simple local alarm. We talked about the communication module, the adapters, the different controllers, the analog and digital DC controller, the Sage CE computer controller. So you've got the grounds to customize any requirement for customers. Experience. We've been customizing fixed point gas detection systems for over 43 years. It's made in the USA. All of our equipment that's patented here in Northvale is made in the USA. So if there's any parameters of your municipalities that are requiring you to have that made in the USA, you have that. Customer service. It's obvious. Anyone who has to have to talk to the company to get your answers or your customers, we offer a better support. We're not owned by someone who's owned by somebody who's owned by somebody. We're the manufacturer. So we can answer your questions and your needs a lot quicker. And then the turnkey systems, we did mention that. We can customize with enclosures and heat exchangers and delays, and auxiliaries, relays, and horns and lights. We really can customize any gas requirement our customers have. So that's pretty much the overview. This Delphian webinar series, everybody received the Delphian overview to understand the product line. We then went to the fundamentals of gas detection to understand the technology better and be able to be sharper and specialists compared to our competitors. This is the third, the GazTell series, which gives you the entire overview. We're looking at doing the Determinator next, because the Determinator has no competition on the market with the ability to have either a mixture or to have up to 5 different gases in the head. It'll identify it and it'll prioritize those gases. in one process transmitter head. So we're looking forward to doing that. I hope you all got a good understanding of the GazTell series and picked up things. Some of you are experts, and I'm hoping that you did pick up some additional, knowledge. If there's any questions, please feel free to email me. But before we get off, I'd still like to run that GazTell calibration video prior to us jumping off the phone. I know we went over time, so if you have to jump off, you please jump off. But I know there's some people on the phone that are going to want to see the calibration video, so I'm going to run that after this. Scott, do you have any other?
No, I'd just like to thank everybody for joining us today. And I do want to make one statement. I did say one thing incorrectly, and I'd like to correct that. When we were talking about the flame arresters not being able to absorb water, I said anaerobic or aerobic. I meant hydrophobic is the correct word for that. So without any other delay, we'll go right to the video.
Okay, I'm going to go ahead and run that calibration video. I think it's a good thing to run. Any of you who need to jump off, please jump off. Here comes that video, as we discussed.
Calibration of the GazTell 450 is simple and fast. Calibration can be performed through either the detector head, or if that's inaccessible, the extension module, also known as the exponent. To calibrate, cylinders of both clean dry air and the span gas will be required. For hardware, you will need a magnetic calibrator, the gas cylinder regulator, and the Delphian sensor gas connector, which comes with 3 feet of tube. Begin by snapping the gas connector, also called the calibration cup, to the bottom of the detector head and apply clean dry air to the sensor. Using the magnetic calibrator, start the zero calibration sequence by holding the red end of the calibrator over the cal mark on the label for 5 seconds. Apply zero air will be displayed. If you haven't already, turn on the zero gas regulator valve. The display will inform you when the gas flowing has removed the humidity from the sensor chamber to allow the zeroing to begin. The entire zeroing sequence typically takes about 30 to 40 seconds. After a successful zero calibration, zero OK will be displayed. If you get a calibration error, calibration has failed. An unsuccessful calibration may indicate an erratic sensor, a bad zero, or bad zero gas. You should make more than one attempt to calibrate zero. If the zero calibration was successful, nothing more is done. The detector will go back online after 120 seconds using the new zero calibration values. This is only true if the detector has been successfully calibrated before. If this is the initial calibration of a new detector head, span calibration must be performed. Make sure you turn off your gas valve. To start span calibration, connect your span gas to the calibration cup and turn on the gas regulator valve. Hold the red end of the calibrator over the cal mark for 5 seconds. The display will scroll apply span gas or spanning if the sensor recognizes that the gas is being applied. The spanning sequence typically takes about 30 to 40 seconds. After a successful span calibration, span OK, remove span gas will be displayed. Turn off the regulator valve and remove the calibration cup. The gas will slowly dissipate from the sensor chamber, but this can be sped up by applying zero air to purge the gas. The detector head will display the gas reading, but will not resume normal operation until the gas has dissipated to less than 5%. If the span calibration was unsuccessful, calibration error will be displayed indefinitely. To clear this, hold the blue end of the calibrator over the cancel mark for 5 seconds. The detector head will return to its original span value and will need to be performed again. An unsuccessful calibration may indicate an erratic sensor or bad span guess. You should make more than one attempt to calibrate span. Please refer to the owner's manual for more specific detail and explanations on calibrating a GazTell 450 detector. This concludes the calibration portion of the GazTell 450 video.
I just wanted to thank everybody who decided to hang on and watch the calibration video. I just thought that completes the series. That completes what we have to talk to our customers about. Are there any questions that I can address? Okay. If you
California is good.
Good. Thank you, California.
Thank you too. Appreciate it.
All right. So if you come up with any other questions, please let me know. I will get you a copy of the PowerPoint as well. And thank you again for investing the time in this. And we'll talk to you very soon. All right, take care.
Thank you, Rob.
Bye.
Thank you, Rob.
Thank you.
Thank you.
Thank you.
Thank you, Rob. Thanks, Rob. Thank you.
Thank you, guys.